Okay, let's talk about some problem like the pH of very dilute solution of strong acid. What will be the pH? Like, so the H plus ion, so the H plus ion from the, I think two things are there. One is the acid and very dilute. Dilute in means in water, H2. So two type of H plus ion will be there. One will be from strong acid and another will be from the H2, like in from hydrogen, like in water, like 10 to the power minus 7 molar. So we are diluting very million, like million fold or more than dilution. So for that purpose, it be like the from strong acid the H plus ion will be much lower than the H plus ion present in the water. So like pH will be, pH will be slightly less than. So that means, if the strong acid it's million fold dilute, then the pH is kind of less, it will be there than the water. That is the thing. Now less than the H2, that is the thing. Like not too much, not too much acidic, but it is mildly lesser than the water. Let's talk about the another question, like the pH of 10 to the power minus 8 molar HCl. What will be the HCl? So now we know about that the H total. First we have to know about the H plus total. So H plus total, it means H plus in water plus H plus in acid. So H plus in water, you already know that 10 to the power minus H molar, plus H plus in acid like the 10 to the power minus 8 molar. So like 10 to the power minus 7, it will be like 1 plus 0.1. It will be 1.01 into 10 to the power minus 7. Let's talk about the pH. So pH, it means pH equals to negative log of concentration of H plus ion. Okay, so minus log of 10.01 into 10 to the power minus 7. So it will be like minus log of 1.01 minus log of 10 to the power minus 7, because it's a initial, it's a minus, so that means minus log of 0.1 is 0.04 plus 7, it will be like 6.96. So the 0.8 molar HCl, that although it's a 10 to the power minus 8, but still their pH will be the 6.96. Hope that you guys can understand that the pH of the 10 to the power minus 8 molar of HCl. Now let's talk about another question. That's very important question, like mixture of two acidic or basic solution. What will be the condition? Mixture of two acid or basic solution. So that means let's talk about the equal volume. Let's think about that will be in the equal volume. Equal volume of two solution. Let's take 100 ml, 100 ml of pH 2 and 100 ml of pH 4. Let's talk about it. So that means if you think about that the 100 ml of pH 2, that means the concentration of H plus ion is 10 to the power minus 2 molar. This color is not good. So concentration of H plus ion equals to 10 to minus 2. The concentration of pH, the concentration of H plus ion equals to 10 to the power minus 4 molar. Now you have the total 200 ml of the solution. Now we have to think about that and what will be the mixture. So in first case 1000 ml 10 to the power minus 2 mole. For second case, sorry sorry, this will be there. Okay, so for 1000 ml 10 to the minus 2 mole, if it is 100 ml, then it will be like 10 to the power minus 3 mole. Fine. So similarly, from that case, if it is 1000, it will be ml, it will be like 10 to the power minus 4 mole. Now the 100 ml, it will be like 10 to the power minus 5 mole. Let's into 200 ml. Let's take another page. So in 200 ml, I think page color it's not looking good. Let's take white. Pattern is there. Okay, let's talk about the 200 ml. In 200 ml, what will be there? Like 10 to the power minus 3 mole plus 10 to the power minus 5. So it will be like 10 to the power minus 3, 1 plus 0 0.01. It will be like 1 0.01 into 10 to the power minus 3 in 200 ml. So so 200 ml 1.01 into 10 to the power minus 3. Now in 1000 ml, what will be in 1000 ml? Into 5. 5 into 0 0.5 into 10 to the power minus 3. Now pH equals to minus log of concentration of H plus ion, like 5.05 into 10 to the power minus 3. Now you can say log of this plus log of that. If you may mention in the calculator, it will be like 2.3. So if you cannot understand the 10 to the power minus 5, it means 10 to the power minus 3 into 0 0.01, then it will be like in the outer part and this, so the pH will be the 2.3. So two solution. In the first solution we have take the 2 and 4. It not means the, if you mix in the equal amount, it not means the 3, it will be like 2.3, because in the, that is in the logarithmic scale. That is the basic thing of that. Hope that that kind of things will be very easy for you. Now hope with that example you can understand much better. Let's talk about the like, for that kind of question you can make some another question like 500 ml of pH 3 and another 500 ml of pH 4. How you can be solved? So basically you have to go through that kind of problem. So like 10 to the minus 3, 10 to the minus 4, then what will be happen? Always you go for 500 and then go for 500 and then mix up. And if you mix up, it will be like already it will be like 1000 ml. And if it is 1000 ml, then H plus ion, you just calculate the H plus ion and then put in the formula. Hope that you can make it more prominent, and also you go for that. Let's talk about some of the weak acid. Let's talk about the weak acid. Let's talk about weak acid. So weak acid means do not dissociate completely, and the acid strength do not directly provide concentration of H plus. So that means if you take HA, that H plus plus A minus, but the percentage of dissociation get changed. Like which percentage of the dissociation, that's very critical. Like that's why the another key term is coming, that is called the dissociation constant. That is a Ka. So like dissociation constant or concentration also, that can be vary, depends on the mathematics. Like if you talk about the Ha, like H plus plus K minus, then talk about the what will be the Ka. Ka will be the concentration of H plus ion plus K minus ion divided by the concentration of Ha. Then if Ka is more value, then it will be the strong acid. So that is the concentration. Now the concentration of H plus and K minus, and it will be like and this is the intermediate of this dissociation. Hope that you can understand that. Let's talk in another section. Calculate the pH of weak acid by 10% dissociation. So if take 0.1 molar CH3 COOH. So if they are 0. Like 0.1 molar, it means uh, and also you said that the 10% dissociation. What will be the what will be pH? What will be the 10% dissociation? Then you can just easily do it like 10 by 100, 10% into 0.1 molar, it means 1 by 10. So it will be like 10 vanish 0.01, 0.01, it's mean, or you can say 10 to the power minus 2. Okay, let's pH equal to minus log of 10 to the power minus 2 2 তাহলে হয়ে যাবে 2, so it will be like 2. So pH will be 2, 0.1 molar acetic acid, the pH will be 2. Hope that you guys can understand that math. That's not too difficult thing, but you need to more practice and practice. So and what will be the pH of acetic acid? 0.1 molar. Let's calculate 0.1 molar acetic acid, CH3COOH. I think this one. And if it is in the 1% aqueous solution, and for this math, it's like dissociated by the 10%, it is there, and now it is in the aqueous solution. Like H plus ion equal to 0.01 1%, it means into 1 by 100, like 0.00 1 or 10 to the power minus 3. Now pH equal to minus log of 10 to the power minus 3, that will be like 3. pH will be 3. Hope that you guys can understand this, and yeah, okay, take the new page. Okay, now calculate, so background white, yeah, now the calculate the pH of the 0.1 molar hypothetical acid with the K value of 10 to the power minus 5. So what will be the solution? Like Ka value is given 10 to the power minus 5 and 0.01 molar. So already you know Ka equals to concentration of H plus ion plus concentration minus by Ha. So like you know about that the 0.01 molar concentration plus 10 to the power minus 5, already it is given like K value is given, sorry Ha value I have to calculate first, that is the Ha equals to 0.1 molar and Ka given 10 to the power minus 5, H plus ion equals to A minus ion equals to X. Let's take now, oh sorry, let's we have to calculate the pH. It means we have to calculate the H plus. So Ha 0.1 into K value, this one like 10 to the power minus 5 divided by A equals to X. A equal to X means the X square, like it will be like X square equals to this, X is equal to 10 to the power minus 6, like X is equal to 10 to the power minus 3. Now X equals to pH, so pH equals to minus log of 10 to the power minus 3, it will be like 3. So pH will be 3. Hope that you guys can understand this math, and also the strong acid and the base. Then we can talk about some of the pK value, and what is the pK value and for weak acid, and the relationship of the logarithmic of that K and dissociation along with the pK value. So let's talk about the pKa. We have to know about the pK value equals to minus log of K value. We have to remind all those things, and also strong acid, it means the high K value, low pK value. Weak acid, low K value and high pK. So pK is the pH at which the concentration of the weak acid and its conjugate base will be in the equimolar concentration. So what is the pK? So like pK, what is the pK? pK means the concentration of weak acid and its conjugate base will be in the equimolar concentration. Now written down it. The concentration of weak acid and its conjugate base will be in equimolar concentration. Hope that you can understand, like the Ha 50% dissociation, like H plus plus A minus, that will be there. Now the acetic acid, the pK value is acetic acid pK value will be like 4.76. So then, like, if pH equals to pK, then the means acid equals to base. And if pH less than pK, then it will be like pH that denotes the, then it will be like acid base. And reverse is also true. Hope that you can understand with that pH and pK value, and along with the strong and the weak acids. Hope that you guys can understand in that class. And in the next class we'll discuss about some of the buffer and how you can make some buffer, and on what is the buffer and how you can generate the sum of this calculation. Something it looks like tricky, but everything it is very easy. So for today, bye bye, tata.